Hello and welcome to the screencast on compound interest. Let's take a look at what exactly is compound interest. So let's say you have a certain deposit of say $1,000 in the bank, and the bank pays you an interest rate of 5%. Now, usually interest rate is given in an annual term. So 5% is the annual interest rate or per year interest rate. So then you would get at the end of the year uh, an amount of $1,000 times 1 plus your interest rate. Now this is straightforward, right? You get a $50 interest rate on your $1,000 amount at the end of the year. Now what if the bank says that it offers to compound your interest rate twice in the year? That means once every 6 months. Well, so then let me just move this here, and times compounded per year is not 1, but it's actually twice. Okay, so now what do you do? Now what you do is, let's say you have January 1st, you have $1,000. On June 30th, you have $1,000 times 1 plus your interest rate divided by 2. So that's important. Now, when the 5% interest rate was quoted, that is for the entire year. And if you want to measure the interest applicable for 6 months, you have to divide that by 2, because 6 months is half of 1 year. And now you have 31st December. Now you apply the same procedure. You take the balance that was there on June 30th and multiply that with the interest rate that's applicable, again 5% divided by 2. So you have $1,050.63, which is slightly different from this amount here. Of course, we're talking about $1,000, and so the amount is small. But if you're talking about millions or billions of dollars, then obviously this is going to add up real quick. Okay, now another way to look at this formula is to say that instead of saying C2 times 1 plus C3, you say C2 times 1 plus C3 by 2 raised to the power 2. And if I were to make this two decimal places show up, then it will be the same as this. Okay, now what if the times compounded is 3? That is, what if the company, the bank is offering to compound your interest rate thrice in a year? So that means now you have 1st January, $1,000, 30th April, that will be $1,000 times 1 plus interest rate divided by 3, and August, 31st August will be this amount times 1 plus interest rate by 3, and then you have 31st December, same procedure, 1 plus interest rate divided by 3. So you have a slightly different figure now, $1,050.84. And if you were to change this formula here, you'll see that it becomes $1,050.84. Now, what is the most general formula for the number of times compounded? That would be this figure right here, deposit times 1 plus interest divided by times compounded raised to the power times compounded. To go back to our Excel spreadsheet, if you just make a small change here, instead of this 3 here, I'm just going to put the times compounded, and instead of this 3 here, again I'm just going to put the times compounded. And so that is a general formula for the total amount that you will earn if your deposit is compounded at a certain number of times. So let's say if you compound it 8 times, then it changes appropriately. So what I'm going to do now is put this in the form of a table. Say, let's say times compounded, and let's say amount. So if you compound it once, 2 times, 3 times, 5 times, 10 times, 20 times, 50 times. Okay, oops, let's just change the format here. Okay, now the amount that is due to you is the basic deposit times 1 plus the interest rate divided by the times compounded raised to the power the times compounded. And I'm just about to copy this formula down, so before I do that, I just put dollar signs before the deposit amount and the interest rate so that I don't change those values when it copies down. I'm just copying it all the way down here, and you can see that these are all the different amounts that correspond to the various number of times compounded values. Now what happens at the extreme when there is continuous compounding, which brings us to the focus of our talk, this particular screencast. When you compound it continuously, then in the limit the value tends to e raised to the power of the interest, where e is the exponential number 2.718. Excuse me. So let me just write this here: continuous compounding. The value would be the deposit times exp to the power exp of the interest rate. So that would be the amount here. So you can see here, if you were to continuously compound this, the $1,000 at the 5% annual interest rate, what that really means is you're compounding it every second or every millisecond or whatever, right? And in that case, the total money that you will receive is $1,051.27. And you can see here that as you increase the times compounded number, the value tends towards 1,051.27. So let's say you make this really large, it becomes 1,051.27. So in the limit, this is what your total amount earned will be. And so that's hopefully a good example of continuous compounding. Thank you for watching this video. I hope you enjoyed it. Thanks.